Okay, in this problem video, we're finally going to put together all of our nomenclature rules that we've learned for dealing with ionic substances. Now, I have a reminder here at the top and on the side about the numeric prefix. The only time that we're going to use the numeric prefix for our ionic substances is when we're doing hydrates. Because remember, if I tell you that we have sodium chloride or calcium chloride, the chloride tells me it's going to be a -1. Calcium tells me that it's a 2+. And in order to make that work, if I have a +2 and a -1, I've got to have 2 of the -1. So CaCl2 will be calcium chloride. You see, I didn't need any numeric prefixes in there. It was already inferred directly from the charges that were available. So make sure when you do these nomenclatures, only use numeric prefixes for hydrates whenever you're doing ions. Now, here are the 8 that I've come up with. 4 of them take you from formula to name. The other 4 take you from name to formula. Go ahead and pause and give it a try. Okay, let's take a look. So I have sodium ion. Now I could write the word ion if that's all I'm going to do is write that I have Na+. But I know that I'm about to make the whole name for it, and the word ion won't appear in the middle of the name, as you can see in some of the examples down below. So I'm going to leave the word ion missing for the moment. Now next up, I'm going to have my O2- to pair up with those Na +1s. If I have 2 +1s, that's a total +2. The O double- counteracts that. So I use my name for the monatomic. It gets the IDE ending for my cation. So this will be oxygenide, which we shortened and made into a speakable word, oxide. So this will be oxide. Sodium oxide. Next up we'll have, let's see. Okay, so next up we have barium. I'm only capitalizing this because it's the beginning of the line. Remember that our names aren't like special. They're not, a person's name. So we don't actually have to capitalize them unless sentence location requires it. So barium. Now I look inside of the parentheses. I've got a nitrate ion sitting there. The nitrate ion is a single minus. Barium is a double plus. So barium I'll just write as a 2+ for a second. My nitrate is a -1. I go to make sure I have a good sense of things. Sure enough, I have 2 single minuses, give me a double minus, compared to a double plus. That's going to work out. And that's my way of double checking to make sure I'm not about to do something silly with my charges. So, barium nitrate. And again, no numeric prefixes or suffixes anywhere in there. So next up we have Mg3N2. We're going to have magnesium. We have magnesium. Then we're going to have nitride. We know it's nitride and not nitrate because the ate and ite ending are from our oxo ion families. If there's no oxygen associated with that atom, it doesn't get that ending. It gets the IDE. So this will be a nitride. Again, I don't need any signs. Let's give it a check just to make sure things are realistic. Nitrogen is in group 5. So for it to look like a noble gas, it grabs 6, 7, 8. It'll be a 3-. So nitride will be a 3- times 2 is a total of -6. My magnesium is going to be in group 2. Group 2 plus 2. Plus 2 times 3 gives me a total of +6 contribution from all of those. So this will be charge neutral just like I expected, and that's good. Next up I have Cu, so that's going to be copper. Oh, but it's going to be copper and it's a transition metal. And that means it can have multiple charges, and I remember that copper can have a couple different charges. That's why I made a point in the other video that it can be cupric or cuprous. Well, let's go ahead and figure out which copper ion it will have. So it's a sulfate ion right here. Sulfate is always going to be a -2. we don't put the parentheses around it when we don't need them. Like here we did to make sure we were explaining that this was multiplying this by 2. We didn't need it here, but I'm going to show it for a moment just to highlight it. This is the sulfate. This whole chunk has a -2. That means the copper must have a +2. So it'll be copper 2. Remember, no space. Copper, no space, parenthesis, Roman numeral 2, close parenthesis, space, sulfate. But we're not done. It's copper sulfate trihydrate. So that'll be its name. Now let's change gears and take names and make them into formulas. So I've got lead 2 chromate. Now for this we're going to have to remember what the chromate ion is. Okay, and it's CrO4 2-. Okay, so I've got a double minus right there. Lead, the Roman numeral is telling me that it's a 2+, so it'll be Pb 2+, CrO4 2-. I'm going to put that together to make the whole formula, and I don't need the charges in that moment. A +2 and a -2, that's easy. So now I just move my Pb over and write Pb CrO4. Notice we still don't need the parentheses around these. It is actually wrong to put these parentheses around it when they aren't needed, so make sure that you're not doing that. It's okay as a middle step when you're trying to get to a solution and you're just trying to keep track of things, but final answers should not have them unless they're required. So iridium 3 bromide tetrahydrate. So we're going to have iridium, and iridium is a transition metal. It's going to be a 3+. We've been told that by the Roman numeral. For the moment, I'm going to write 3+ to keep track of that. Bromide. Bromide is one of my halogens. Bromide will have a Br single minus charge. I've got a 3+ and a single minus. I've got to have 3 of these to get that to be a -3 overall. I'm at +3 and -3, so that's all neutral. I'm going to scoot this over. Ir Br3. But we're not done. We have tetrahydrate. Tetra, 4. Remember tetris. We put the dot right there in the center. We write the number 4 and then H2O. So that'll be iridium 3 bromide tetrahydrate. See, a lot faster than spitting that mouthful out, right? Now calcium fluoride. Calcium 2+. Fluoride minus. Don't write Fl. It's F. Okay, I need to have 2 of these to take care of that +2, so it'll be CaF2. And then the very last one, sodium hydride. Oh, wait a minute, what's hydride again? Remember, hydrogen was allowed to be a +1, at which point we call it hydronium. Or it can be a -1, at which point it's going to be the hydride ion. So it'll be H-. Sodium is going to be Na+. So Na, H-. So it'll just be NaH for sodium hydride. And that's some of our nomenclature. Make sure you're good and polished at doing this, because this is definitely something that persists for the rest of the semester and going into Chem 2 and the rest of your chemical usage in any field that